So hey guys, welcome back to my channel. Hope you are doing extremely well. And this is your very own mask code this side. So today we will be solving yet another problem of POTD. The problem is find shortest safe route in a matrix. So let us have a look. What does the question say? See, it is a very easy problem, right? It is a very easy problem, right? And I will tell you in such a way that this will become more easy for you, right? So what we will do, what is asked to us is that you have been provided with a matrix, right? This is a grid given to you, right? Okay. You are standing in first column. You're standing in first column. Let me change the ink. You're standing in first column, right? Okay. And let me change the thickness also, right? Okay. You're standing in the first column, right? Now, your task is to go from any index. Like you can start from here, from here, from here, from here, from here. You can start from any of these possibilities and you have to reach the last column. You have to reach the last column. That is, either you can reach here, 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 and either you can reach here. Now, the complexity arises when the question says that any cell marked as 0, any cell marked as 0 contains a landmine. So explosion will occur. If you're moving from this column up till this column, right, you have to move in such a way that you don't step over a landmine. That is, you do not traverse that particular cell, right? But the landmine is furious, right? So you don't want to take any risk. And then the question says that you cannot travel on any cell that is adjacent to landmine. So what does it mean to say that suppose a cell contains 0, right? This cell contains 0. Obviously, this is not traversable. I cannot step over it because it's a landmine. The question says that landmine has such a great impact that you don't want to take any risk. So you will not be stepping over here. You will not be stepping over here. You will not be stepping over here. You will not be stepping over here, right? You cannot traverse the adjacent neighbors of the landmine also, right? Apart from this, you can travel. You can see that I have not marked diagonal. Diagonals are traversable. Diagonals are traversable. You only have to take care of up, right, left, and down, right? So I think I'm clear up till now with what you have to do, right? Now you have to provide me the minimum steps to reach last column starting from first column, right? Given this condition that landmine and you cannot travel on the adjacent sector, right? This is the basic input, right? Now, how do you solve the problem? How do you solve the problem? So let me erase this, right, and make it good to go. Right? Just a second. Give me a moment. Yeah. Now, what can I do? I will say that since it asks me to find the minimum, it asks me to find the minimum. Now, minimum will be found out from all the existing cases. Minimum can be found out from all the existing cases, right? Existing cases. And when I have to tell about all the existing cases, my clear indication is to use recursion. Recursion. And when we are solving for recursion, we should see that is it possible to use memorization in it? If yes, convert it to DP. If no, sorry mate, we will going with the recursion only, right? This is an optional task for now up till now. Okay. We will first have to master recursion. We will first have to master recursion to solve this problem, right? So I will twist some things up right now, right? I will start from this. I will start from last column and find the maximum number of steps I will have to take to reach the first column. And I want you to give me the code in the comment section of going from first to last, right? only some things will change, right? You don't have to change much of the code, you have to change some of the code, right? So I'm actually at last column. So what will I do? So I will traverse, I will try the traversal from all these nodes, like this node, then this node, then this node, then this node, then this node, right? So I'm currently here, I'm currently at this one. This one will be traversing here or here, right? Because there is no up, I will not be going up, right? This one can go at this one or this one, right? Okay. Now this one, the first traversal, can go this one or this one, right? Only these are possible. Now this one is not a traversable option. It is not good because it is a adjacent, right? So I will have to check whether a node is adjacent to a landmine or not, or it is on the landmine or not, right? Okay, so I will go here, right? I will see it is a zero. I will say return max. Max has an int max, right? Int max. That it is not possible to reach. I am returning int max for that reason. This recursion call has ended. Now for this, I am here. The case is left for me are I can go here, I can go here. I cannot go up. Why can I not go up? Because I'm coming from there. This particular index is already visited. This particular index is already visited. So I cannot go to the visited one, right? Why will I go to the visited? What I'm saying is you have to go from left point to right point. And you are saying you will go like this. 1, 2, then 1. Like 1, 2, then 1, 2, then 1. Are you drunkard or not? Right? So you will not go beyond. That will you will not traverse the backward. You will not go to the already visited node, right? Okay. But these one node, two node, and should I traverse this node? No. Why? Because this is taking me away. This is taking me away from my final target. This is taking me away from my final target, and I would not like to do that, right? This case can be dealt from this case also, right? From above case also. So I will not tell, I will not be doing right. So my first conclusion is no right. Okay. So this traversal starts now. In this traversal, I will be going here or here. First, let us explore this. This can go here or here. Okay, let's explore this. Is it possible to go? No, this is adjacent, so it will be returning max. Now this, it is how many possible? Here or here? Going for this here. Oh, we have reached the first column, so it will return me one. This will add one to it. This will return two. This will add one to it. This will return three. This will add one to it. This will return four. This will add one to it. Five, six, 7. So this is actually turning 7 up till now, right? 7 up till now from the first traversal we have made, right? Similarly, it will go here, then here, then here, then it will return something else, then it will return something else, and it will return something else. So this is my basic flow of the recursion. See, it is very impractical to solve all the recursion here, right? It is very impractical to solve all the recursion. I was just trying to give you an idea that we will be going with no right, and we are traversing from last column to left first column, and we are checking if any column is uh, not traversable or not because of the landmine, right? So I hope you are familiar with that. So let us write the pseudo code for this. Let what like what we were doing, right? So the pseudo code, right? So the pseudo code would work something like this. This is my driver function, right? My driver function, right? My driver function. Now this driver function has my matrix in it, right? Let us say the number of rows are rows, number of calls are calls, right? Now what will I do? I will first create a visited array. I will first create a visited array of same dimension, rows and calls, and set them all to false. Right? Set them all to false. That they are not visited up till now. They are not visited, right? All of them are unexplored. Now, I will initialize my mini, that which is my actual answer, as int max, right? And then my first thing I said in the algorithm is I will traverse all of them. So for that, I will have to use a loop that will take me to the different rows, right? So for I going from 0 up till my rows, right? Mini equals to, try to understand what I'm writing, minimum of the existing mini and the existing mini and solve matrix for that row, that column, sorry, m minus 1 column, m is number of calls here, m minus 1 column, and visited array, right? Now, after this for loop, if mini remains to be int max, if mini remains to be int max, when will mini remain to be int max? Mini will remain to be int max only when there is no case I can reach from the first column to last column or to last column to first column, right? Mini will remain int max if there is no way I can reach from last column to first column. In that case, we have to return -1. So if mini equals to int max, that means return -1. I cannot reach. Return -1. Else, return your mini. Right? So this is my driver code, right? But here we declared solve. So I will have to declare the function solve now. I will have to declare the function solve. Let me change the ink for solve. Let me make it more interesting for you, right? Solve. What is solve taking? Solve is taking my matrix, my row, my call, and my visited, right? First thing I have to check if this row and this column is existing in the matrix. So for that, if row is greater than equals to 0, right? Row is uh, less than n, where n is the total number of rows, right? Call is greater than equals to 0. Call is less than m, where m is the total number of columns, right? Also, I have to check if visited is false. If visited is false, visited of row call is false. That is, I'm not traversing the parent again, right? So false. Also, I will check uh, landmine free, landmine free of row call. What will this function return me? This function will tell me if it is safe to traverse that index, right? Okay, now if all of them are true, only then it will return. Else, in the else case, we will return int max. In the else case, we will return int max, right? So first operation you will do is you will say make this true that I am explored it, right? I am currently exploring it. Now I will have three cases left: right, up, down. Four cases, and this will be taken out. Right is actually taken out. Why? Because I explained that I will not go further from my target, I will go towards my target, right? Now left is equals to the number present on that row and column plus solve for left one. If I'm currently at ij and I want to go left, I am decreasing my column number and keeping my row number same, so I comma j minus 1. Solve for row comma call minus 1, right? Similarly for if I am standing at I am going up, it is I minus 1 j, right? So solve for row minus 1 call, and for down it is going to I plus 1 j, right? So solve for row plus 1 call, and these all things will remain same, right? Mat row call plus solve, etc., right? And at last we have to return minimum because the task was to find minimum, so we will returning minimum of left of minimum of up down, right? This is my whole code, and the else for this condition will be return max, right? So this is the whole code. The only thing I want to add now is you will flabbergasted from that is after this you have to make that row call as false. Now many of you will say why? Just hold on. We are here to solve your doubts only, right? Okay. So in this matrix, suppose this vertex was traveled as in this route, right? And it was returning 8 to me somehow, right? Now this has to be traversed in this route also, and this should be returning 4, right? But we said that if it is from parent, then return false. So how are we checking parent if it is already traversed? So for this in path, it is not traversed, but because of this path, this is already marked as true, right? So make it explorable for this path also, we have to mark it as false. We have to mark it as false. This is the only reason, right? Something sort of when you are doing the cycles, detecting cycle in a graph, right? You do the same thing, detecting cycle in directed graph, right? What do? You take visited and path visited, right? Something sort of that, not exactly, but something sort of that, right? So I hope you are familiar with the code now, you're familiar with the pseudo code now, and you don't have any problem, right? And it's time for us to move to the actual coding area now. If you're new here, I hope you will subscribe to my channel because you're liking these videos so much, right? Okay, so my number of rows that I'm storing in n is mat dot size. My number of column is mat of 0 dot size. Now I will declare vector of vector int viz, and it will be double cursive here, and vector of int m comma 0, initially all initialized as 0, right? That has not visited, right? Now what I will do, I will make int mini equals to int max, right? Now for int I, going from 0 I up till n I plus plus, mini equals to min of the existing mini, and solve for my row with my last column, that is m minus 1, and send my matrix with my visited there, right? Okay, and now if mini equals to int max, in that case return minus 1, else return mini, right? Okay, now we have to declare the solve function. So solve is returning int, so int solve first is row, let us name it as I and I comma j only, that will be easier to implement, right? Int I, int j, vector of vector int uh, matrix, and vector of vector int visited, right? Okay, now our first condition is if I is greater than equals to 0 and j is greater than equals to 0 and I is actually less than equals to mat dot size, that is total number of rows in the column in the matrix, and j is actually equal to mat 0 dot size, number of columns, right? Number of columns. And now j is less than equals to mat 0 dot size, I is less than mat dot size. Now visited should be false because it should not be pass visited right now. Visited should be false, that is 0, right? And check for send my matrix I and j, that is it should not contain any landmine. We will be implementing the check function also, right? If these all are true, then proceed further, otherwise go in the else case and return int max, right? Now in this case our first operation was to viz of ij equals to 1. Now int left is equals to mat ij, oh sorry, int left equals to solve for I minus 1, I will remain same j minus 1 with mat and viz, right? Similarly int up was equal to solve for I minus 1 with j, mat and viz, and int down is equals to solve for I plus 1 j, mat, viz, right? Now if left is equals to int max, then I don't have to add anything, I will remain same. But if it is not equal to, I will add my matrix cell value, right? Left plus equals to mat of I j, right? Similarly for up and down, so if up is not equals to int max, up plus equals to mat of I j, and if down is not equals to int max, down plus equals to mat of I j. Now return min of up with min of left down. That is min of all of the three, right? So up till now code is running, the code should be fine. Just have to implement the check function. So check is returning the bool value. So bool check, taking my I, taking my j, and vector of vector int matrix, right? Now if I minus 1 is actually greater than 0, that is, so what I'm saying is, if suppose my I comma j is lying here, right, the neighbors are only 0 and this one, there is no neighbor like this, so I have to avoid segmentation fault, I will have to add some constraints, right? So if my I minus 1, that is my I minus 1, that is my previous row, is in the matrix, is not out of bounds, then only check. If I minus 1 is greater than 0 and mat of I minus 1 j is equals to 0, in that case return false, because the landmines is present on the left side. Similarly, if j minus 1 is greater than 0 and mat of I j I sorry j minus 1 here is equals to 0, in that case also return false. Similarly, if I plus 1 is actually less than equals to is actually less than mat dot size, that is number of rows, and mat of I plus 1 j equals to 0, again false. Similarly for j plus 1 with column numbers, right? So mat of 0 dot size and mat of I plus 1 j. So it will be I with j plus 1. 0, return false. If all of them are returning not executing correctly, then return true. That is, it is not an landmine, right? So I hope this code should work fine. Let us compile and run it. In the meantime, I would like you to subscribe to my. Oh, there has been an error. Sorry. There has been an error. What is the error? No matching function for call. Check mat ij. Oh, it is check mat ij, and I have, yeah. So check. It should run fine now. So you can see it is running fine for compile and run, but it will give TLE, most probably it will give the TLE in the case, right? Because I have to implement TP right now. Oh, it has been running fine, but sorry, we will be implementing TP also because that is possible in this case. So vector of vector int, and I will declare TP of size n plus 1 with vector of int m plus 1 and minus 1, right? That is a standard procedure, and I will send my TP with it, right? I will send my TP here, and I will send my TP here, that is vector of vector int and TP, and I will say here that if dp of ij is not equals to minus 1, return dp of ij, and in all the function calls I will say same thing, send the dp, right? That is pretty basic, right? I don't think that needs proper explanation. That is only the memorization works, right? dpij. Let's try to compile and run it now. Hope I've not committed any mistake in getting dp array running fine. It will work for submit now also. So 1 2 3, let's see the magic, and it is run. Okay, thank you guys for watching my video, and the journey has been a quite up and down and very good for me. Thank you for watching, and thank you for connecting me, and we meet tomorrow with a new question. Thank you for watching. Bye.